Hello students, welcome back. Let's take a look at exercise, let's continue in fact with exercise 8.1 of chapter 8 quadrilaterals. We'll solve question number 6 today. So we've been given that quadrilateral ABCD is a parallelogram and diagonal AC bisects angle A. So what does this mean? That angle DAC is equal to angle BAC. We need to prove that diagonal AC bisects angle C. So we need to prove that DCA is equal to BCA. Also we need to prove that quadrilateral ABCD is a rhombus. So getting back to our definition of rhombus, what do we know? That rhombus is a parallelogram in which all the sides are equal. But it's already been given that the given quadrilateral ABCD is a parallelogram. So what do we need to prove? That all the sides are equal. That is AB is equal to BC is equal to CD is equal to AD. Now first of all, if you see all these markings out here, why I have marked these dashes and arrows? Because my quadrilateral ABCD is a parallelogram, therefore AB is equal to DC as well as AB is parallel to DC, because we know that for a parallelogram the opposite sides are equal and parallel. Similarly, AD and BC are parallel and equal both. So now we need to prove that diagonal AC bisects angle C. So we need to prove that DCA is equal to BCA. Let's mark our angles as 1, 2, 3 and 4. So I'll mark this angle as 1, I'll mark this angle as 2, this angle as 3 and this angle as 4. Now what can I say? That angle 1 is equal to angle 2. Why? Because AC bisects angle A. So let's write this down. Let's start with our proof of my first part. I'll say angle 1 is equal to angle 2 since AC bisects angle A. But what do we have? DC is parallel to AB. Therefore, angle 3 is equal to angle 2 because they form alternate angles for parallel lines DC, AB and transversal AC. So, first of all, I'll mark this as 1. I'll say DC is parallel to AB, opposite sides of parallelogram, and AC is the transversal. Therefore, what can I say? That angle 3 is equal to angle 2. I'll say alternate angle theorem. So what do you get from 1 and 2? From 1 and 2, you will get that equals are equal to the same thing, therefore they are equal to each other. So I'll say therefore angle 1 is equal to angle 3. Let's mark this as, first of all, let's say from 1 and 2, and I'll mark this as my third equation. Now similarly, if you see that AD is parallel to BC and again AC is my transversal, therefore what can I say? That angle 1 is equal to angle 4. So let's write this down. AD is parallel to AB, AD is parallel to BC, opposite sides of parallelogram, and AC is the transversal. Therefore, what do I have? That angle 1 is equal to angle 4. Why? Alternate angle theorem. Let's mark this as 4. So what do you get? Now see, 1 is equal to 4, but 1 is also equal to 2. Therefore, what can I say? From 1 and 4, 2 and 4 are equal. Therefore, angle 2 is equal to angle 4, and I'll say from 1 and 4. And also over here, if you see your fifth, if you mark this as 5, you see that 2 is equal to 5. From 2 and 5 you can say that 3 is equal to 4. Why? Because see here, you have 3 here, angle 2 over here and angle 2 over here as well. So, from 2 and 5 you can say that angle 3 is equal to angle 4. From 2 and 5. So, what does this mean? That this implies that angle DCA is equal to angle BCA, which means that AC bisects angle C. Let's mark this as 6. So, we have proved this part that diagonal AC bisects angle C. Now, let's proceed and show that quadrilateral ABCD is a rhombus. So, we need to prove that AB is equal to BC is equal to CD is equal to AD. So, how do we prove this? First of all, we just prove that 1 is equal to 3, right, over here in my third section. So, what happens is that they form the base angles of my isosceles triangle. Therefore, I can say that AD is equal to BC. Similarly, we prove that 2 is equal to 4. Look over here, 5, right. So, again they form the base angles for isosceles triangle ABC. So, therefore, I can say that AB is equal to BC. Let's write this down, then we will see how we are going to proceed all the how we are going to prove all the sides equal. Proving the second part. So, over here I have angle 1 is equal to angle 3. This is from my third section or equation 3. So, the sides opposite 1 and 3 are going to be equal. Now, which is my side opposite 1? Angle 1 is DC. So, I will say DC is equal to, and the side opposite angle 3 is DA, or I will say AD, and here I will say CD. It is the same thing. CD is the same as DC and DA is also the same as AD, and I will say isosceles triangle theorem. Let us mark this as 7. Again, what do we have? We have 3 is equal to 4. So, have we not marked 3 is equal to 4? Sorry, we have 2 is equal to 4 out here, because we are going to look at this triangle now, right. So, I will say angle 2 is equal to angle 4, and I will say from 5. Therefore, the sides opposite angles 2 and 4 are going to be equal. So, the side opposite angle 2 is BC, and the side opposite angle 4 is AB. Again, I will say isosceles triangle theorem. I will mark this as 8. Now, what do we have? Quadrilateral ABCD is a parallelogram. So, AB is equal to DC, or you can even say AD is equal to BC, because we have seen already over here that the opposite sides of a parallelogram are equal and parallel. So, I will just say, but AB is equal to DC, or AB is equal to CD. Why? Opposite sides of parallelogram, and I will mark this as 9. So, if you observe your equations 7, 8 and 9, you have AB is equal to CD. Look over here, which implies that AB is equal to BC, AB is equal to CD, which is also equal to AD. So, what can I say? Therefore, AB is equal to BC is equal to CD is equal to AD, because equals that are equal to the same thing are equal to each other. And I will say from 7, 8 and 9. Therefore, quadrilateral ABCD is a rhombus. So we have proved this section also. The first section is proved out here, that AC bisects angle C, or you just, if you want, you can, because they want you to mention diagonal AC, just mention diagonal here, the diagonal AC bisects angle C, and the second part that ABCD is a rhombus. So once you prove that all the sides are equal for your parallelogram ABCD, it implies that a quadrilateral ABCD or parallelogram ABCD is a rhombus. So this was about question number 6. We will take a look at question number 7, which is somewhat similar to question 6. It's just the converse. So we will take a look at it in the next video. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.